This is section 7.1. We're going to start working with the trig graphs in Unit 7. So first, let's just kind of look at this. If I have the equation y equals sine of x, then keep in mind the x represents the angle, right? And the y represents the answer to the trig function. So that means that your x-axis is going to represent an angle. Now, normally when we do this, we're going to do our angles in radians, but just to kind of get you started to give an idea, let's think about if the x-axis represents degrees. And this is saying, for now, let's just look for, like, let's say 0 to 90 degrees. So let's say if this is 90 degrees, and I'm just looking at the values I have here for x, 0, 30, 45, 60. So let's see, this could be 30 and 60, and then that would make 45 be right in the middle, right? So I've got my scale pretty close to what this would be. All right, so let's just fill in our chart. So remember the equation, y equals sine of x. So if x is 0 degrees, then y is going to be the sine of 0, which is 0. If x is 30 degrees, then y is going to be the sine of 30, which we know is 1/2. If x is 45 degrees, then y is going to be the sine of 45, which we know is the square root of 2 over 2. And then the sine of 60 we know is the square root of 3 over 2. And then the sine of 90 we know is 1. Okay, so if I'm going to graph these as ordered pairs, then the first ordered pair is 0 degrees, comma, y is 0. So that's going to be this point right here. And then if I'm going to kind of, if I have another ordered pair at 30 degrees and then y is 1/2. So let's say here's where y is 1, here's where y is -1. So at 30 degrees, which is this first line, and I'm up to 1/2, so I'm just going to kind of eye it up 1/2 would be about right there. At 45 degrees, all right, I need to think about square root of 2 over 2, and I don't want to do a calculator yet, so I know that the square root of 2 is around 1.4, so divide by 2, so this is going to be approximately 0.7, that's good enough. So at 45 degrees, I'm at 0.7, and if I'm just kind of eyeing it up, maybe something like that. And then let's see, I know the square root of 3 is 1.7, and if I divide that by 2, it's going to be between 0.8 and 0.9, I'll say 0.85. I mean, I'm just doing a guesstimate, that's good enough. So 60 degrees, I'm almost up to 1, but not quite. And then at 90 degrees, I'm at 1. So right in here. And at first you might think that that's linear, but it's really not. If I were to connect those, it's going to be something like this. Let's see, something like that. Okay, so now that's just 0 to 90. So that's kind of the beginnings of the sine function. Now, think about this. What if I kept going? What if I kept going on out to 180? So let's say, I think that could be about 180. And I'm going to mark off the same increments as I did over here. So I had the 30 degree increments. So this would be like 120, and this would be like 150. And so then the 45 degree increment would be like right in the middle. So I'm going to do some color coordinating here. So remember, at 30 degrees, we were right here at 1/2. Well, which one over here is a 30 degree reference angle? Well, isn't 150 a 30 degree reference angle? So that one's also going to be 1/2. And then let's see, I'll color code the 45 degrees was this point. Well, isn't this the 135? Wouldn't that be the 45 degree reference angle? So that one's going to be like right up here. And let's see, what other color do I have? So the 60 degree was this point up here. And so again, isn't this 120 a 60 degree reference angle? Because remember, reference angle goes to the x-axis, or I should say it's going to the 180 side, right? So that point is up here. And then I could come back to blue and I could say, well, at 180, that's a 0 degree reference angle. So that's going to be where that one was. So, okay, if I had drawn these to scale, this one was down here a little bit. And I think that green one was kind of up a little bit. So if I were to extend that, it's going to kind of be coming back down there. That's if I went from 0 to 180. Well, again, that's only 0 to 180. I mean, what if I wanted to go all the way out to 360? Why don't I do this? I'm going to take this and I'm going to just squeeze it up so I can kind of scooch it over. So this is my 0 to 180. Okay, so what if I were to double that whole thing and go all the way out to 360? So let's say like right here would be 360. Well, I know it's going to be all the same values, right? Because 180 to 360, 360 is going to be the third and fourth quadrant. Well, think about it. Isn't the sine function all those same numbers, but in the third and fourth quadrant, isn't it negative? So that means that I'm going to have that same shape. It's just going to come down here and be negative. Now, if that made sense to you, great. If it didn't, okay, fine. Dismiss it. I just wanted to kind of give you a little bit of the why. Now I'm going to show you what the graph is actually going to look like. And so from now on, anytime we're doing graphing, we're going to be thinking radian mode, because we're going to always call our x-axis in terms of pi, not in terms of degrees. So just to show you, this says, once you're in radian mode, use your calculator to graph y equals sine of x, but I want you to explore something. We're only going to look at the window from 0 to 2 pi, and we're going to let our scale be pi over 2. So that means if this is 0, I'm only going to go out to 2 pi, and every little tick mark is going to represent a distance of pi over 2. So that means this is pi over 2, this is 1 pi, and that would mean this is 1.5, so this would be 3 pi over 2. And it says let the y scale go from -3 to 3. So here's -3 up to 3, and those go in increments of 1. So on my calculator, I'm going to go to my y equals, and I'm going to put in there sine of x, and then for my window, it says I'm letting x go from 0 to 2 pi, so 0. And down here, I'm going to literally type in 2, and then the pi is the second, and then that little caret. See the pi there? Now, whenever you press enter, or if you just move the cursor down to the scale, it'll convert the 2 pi, which is fine. It just did the 2 times 3.14 number. And so I was told that I want my x scale to be pi over 2. So I'm going to say pi divided by 2. And then again, whenever I move my cursor down, it's going to convert that and be the 3.14 number divided by 2, no problem. And then it said I want my y's to go from -3 to 3. So -3 to 3, and they said we want the scale to be 1. All right, so I'm going to hit graph, and it's going to show me the graph of the sine function. Well, that's pretty much, let me scooch it over here. Whoops, where'd it go? That's pretty much like the one we graphed up there, isn't it? I mean, so that makes sense to me. And that's all I was trying to do up above, was to see if it kind of made sense why the graph is what it is. So if I were to transfer that graph onto my number 1 down here, you'll notice it starts at 0, it goes up to 1, comes back through 0, down to -1, and then back to 0. So it's going to look something like this. If I put the points on it, started at 0, it went up to 1, came back to 0, it went down to -1, and then it came back to 0. So it was something like this. And it was a nice smooth curve all the way, right? Okay, now look down here at number 2. It says use your calculator to graph y equals sine. So same thing we just did. But this time, instead of going from 0 to 2 pi, this time we're going to go from -2 pi to 2 pi. So here's 0. I'm going to go from -2 pi all the way over to 2 pi. And I'm still going to have a scale of pi over 2. So all those individual numbers are still pi over 2. I'm still going from -3 up to +3. So all that's going to do on my calculator is I'm going to change my window. Instead of starting at 0, I'm going to start at -2 pi. But otherwise, everything else is the same. So when I hit that graph, it looks like this. Well, it actually, doesn't it look like two of the same thing? Like if I were to draw the left side, it went from here up to 1, down to 0, down to -1, and back to 0. So this was the right side. But if I look at that calculator, doesn't it look like it has the exact same thing over on the left side? where it started at 0, went up to 1, back down to 0, through to -1 and back to 0. It just kind of then connected back up. Okay. So what that means is, looking at number 3, it says compare the two graphs from number 1 and number 2. What do you predict will happen if you were to graph the sine function on the interval from -4 pi to 4 pi? So, I mean, just to kind of show you a real quick kind of thing, if here's 0, 1 pi, 2 pi, -1 pi, -2 pi. So if this is the one that I had a second ago where it did this kind of thing, okay, this is not drawn to scale, it's kind of whipped down there real quick. Okay, if that's what I had a minute ago, then what do you think is going to happen if I extend it out to 4 pi over here, -4 pi, and +4 pi over here? Well, I kind of think that same shape, remember, didn't that shape just repeat itself over here? Well, doesn't it seem like I'll just have another one of those? And then doesn't it seem like I'll have another one of those here? That's what I think is going to happen. Of course, I know what's going to happen. It says, notice the graph repeats itself every how many units? Well, how much did it take to get one full section? Well, wasn't it from here to here? That's the shape that kept repeating itself, right? I've got the same shape right here. I've got the same shape right here. I've got the same shape right here. And every one of those boxes is how wide? Well, it's 2 pi units wide. This means that y equals sine of x is a periodic function. Okay, a periodic function. Okay, periodic means it repeats itself. So that same shape would just keep repeating itself. In this case, it repeats itself every 2 pi units. And so we would say that its period is 2 pi, because that's how long it takes for one full section to repeat itself. Okay, so let's do the same thing with cosine. So in the first graph, I'm going to graph cosine, but I'm only going to look at it, if I can get this to sit up right here, I'm only going to look at it from 0 to 2 pi, because I want to start going to 2 pi. So cosine of x, I'm only going to go, I'm going to set my window to go from, to go from 0 to 2 pi. I still have a scale of pi over 2 and so on. So let me set that up here. I'm going from 0 to 2 pi, from 0 to 2 pi. These are still increments of pi over 2. I'm going from -3 to 3, so they're increments of 1. And so if I were to graph the cosine, it's going to look like this. Just looking at it, it looks like when I'm over at 0, the y value is 1, and when I end over at 2 pi, the y value is 1. And then it comes down through 0 down to -1. Okay, so it looks like the cosine started here at 1. It looks like it came down through 0 and then through to -1, back through 0, and back to +1. But if you look at that graph, it's not just connect the dots and it's going to be a V. No, it was kind of a smoothed curve. So it did something like this. Something like that-ish. And what do you think is going to happen if I extend it and I go out to -2 pi? So I already had my 0 to 2 pi. I know what that's going to look like. Remember we said it goes here, 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 right? It does this kind of thing. But what would you speculate is going to happen if I take it out this direction to -2 pi? Well, if you're thinking like the same thing is going to happen that happened with sine, you'd be right. So I'm going to start at -2 pi and let it go all the way to +2 pi, and there it is. Again, do you see that same shape is repeated? So that same shape over here started at 1, came down through 0, passed through to -1, back through 0, and back up here. So that same shape is repeated, and then it connects back up. Okay, so is the sine function a periodic function? Well, doesn't it look like, here's what I'm looking at, doesn't it look like this shape just repeated itself right? So I think the answer is yes, it's periodic. And what is the period? Well, how far did it take for one full section? Well, from 0 to 2 pi was one full section. So the period is 2 pi. So both the sine and cosine repeat themselves. Both of them have a period of 2 pi. It's just that the shape looks a little bit different in that 0 to 2 pi range. So what I want you to get out of this first section is this. I took you through the calculator information to get what we did. But from here on out, the rest of this unit is not about the calculator. It's about you learning how to graph sine and cosine without ever touching the calculator. Okay, so here are the guidelines that you need to get down. Every single time you graph one section of sine function, here's how you're going to graph it. Okay, so keep in mind that we said the period of the sine function is 2 pi. Okay, every time we graph, we're going to use a scale of pi over 2. Now that doesn't mean you have to write down every individual mark, but that means that one will be pi, that one would be 2 pi, and for our y scale, it's always going to be a scale of 1. So the way I have it drawn, this would go from -3 up to +3, and if I was really going to draw this side, this would be -2 pi, and this would be negative pi. But again, notice I have the little tick marks every half pi. Okay, so here's how, anytime you draw the sine function, here's what you should think to yourself. I think this is an easy way to do it. You need to always have down 5 points. I need to see these 5 points. I need to see them, okay? So first points are going to be to say that the sine function starts, ends, and halfway at 0. Okay, so if the period is 2 pi, I'm saying at the beginning of the period, it starts at 0. At the end of the period, it ends at 0. And halfway, which in this case, halfway between 0 and 2 pi would be a pi, it's also at 0. Okay, so if I'm only drawing the one section of it, here I am from 0 to 2 pi, those are 3 of the points. Okay, then the other 2 points to remember about the sine function is as you move from beginning to end, the sine function goes up to 1, and then it keeps going down to -1. So as I start, I'm right here at 0, I head up to 1, but then I keep following through the points, and then I head down to -1. So there are 5 points, and from those 5 points, I can draw very quickly and easily one full section of the sine graph. Okay, so let me show you. Let's say I'm going to draw another section of it, but this time I'm going to look at the left side, the -2 pi to 0. Okay, I'm not drawing backwards. We always draw a graph from left to right. We never draw the graph from right to left. So when I say starts, since this is the section, let me do something here. Since this is the section I'm looking at right now, right? This is the section I'm looking at. When I say starts, I'm talking about this, because we always start left and then we go to right. It ends, and then halfway, I'm at 0. And then from my starting point over here, I go up to 1 and then down to -1. And so what should happen is when I draw that section, it should very smoothly and seamlessly, if I can draw it pretty well, match up with where the other one started. And notice it's not a choppy connection. It just smoothly goes into the next period. Okay? For cosine, so again, we know that, so now I'm graphing cosine. We know that the period is 2 pi. We're always going to use the same scale. So if I'll go from 0, every line is a half a pi. So this would be 1 pi and 2 pi. So this would be -2 pi, and this would be -pi. The scale for the y's is always going to be 1, so this would be -3, and this would be +3. Okay, so again, there are 5 points for cosine. Okay, and so this is the way we're going to think about cosine. Remember, for cosine, it starts and ends at 1. Okay, so if I'm only looking from 0 to 2 pi, it starts at 1 and it ends at 1, meaning the y value is 1. Okay, and then for my next point, I know that halfway between the beginning and end, it goes down to -1. So I'm going to say here, halfway, it goes down to -1. So the halfway in this case would be at pi. It goes down to -1. And then so that's 3 points. For my last 2 points, I'm going to say halfway, meaning halfway between each of those 3 points. Halfway, I'm at 0. So halfway between the first 2 points, I'm at 0. Halfway between the next 2 points, I'm at 0. And I know a lot of people look at it and say, oh, look, it forms a V. That's fine. That's fine if you think of it that way. But I want you to know, I want you to be consistent with these halfway measures, because this is just the beginning. Eventually, we're going to start squeezing it up and stretching it out. And so these numbers will always make sense if you use these phrases. So when I sketch this graph, it goes something like that. Notice how I always curve through the endpoints. And the reason I do that is because if I were to draw another section of it, if I were to draw another period of it, this will give you a smooth transition. I'll show you what I mean here in just a second. Let's pretend like here's how a lot of students will draw it. They'll just connect and do this kind of thing, like they think it's a parabola, which it's not, okay? But if they do that, when they draw this side, it's going to do something like this, and that is not what the cosine looked like. That's kind of got some pointy stuff to it, all right? However, if you smooth through those endpoints, okay, if you smooth through those endpoints, then watch what happens when I come and I draw another section. So I'm going to follow my pattern. I'm going to say start and end at 1. Halfway, I'm at -1. And then halfway between each of those, I'm at 0. And so when I draw this section of cosine, do you see that because of how I curved through, that when I head up here, as I'm heading up here, it's going to seamlessly connect up. It's not going to look all pointy. And I know that sounds picky, but I'm not asking you to do that much with sine and cosine. We can at least make them look somewhat accurate. Okay? So it's not like there's real homework here. It's just you practicing to draw them. And notice what I've got here. This is saying, hey, practice drawing 1 period of sine. If you're only doing 1 period, do the one from 0 to 2 pi. Or in this case, it says do 2 periods of sine. In that case, go from -2 pi to +2 pi. Or down here for number 3, when it says 1 period of cosine, if you're only doing 1, do the one from 0 to 2 pi. And number 4, if you're doing 2 periods of cosine, do the one from -2 pi to 0, and then again from 0 to 2 pi. So all you're doing is practicing what we just did over here. It's just that you're practicing this concept of draw your 5 points and put the graph down. It should take you like a few seconds to draw each one. Just to give you an example, let's say I'm going to jump down here and I'm going to do number 6. This should be your exact thinking, okay? If you're following this pattern of thought, let me kind of pull it down here for you. If you're following, I don't want that whole thing. Can I squeeze up just this part? Let me see. Well, I'll bring the whole thing down. If you're following that pattern of thought, then here's what you're going to do. You're going to take that, you're going to bring it down here just so I can see it. Okay? I'm going to bring it right here. I'm going to squeeze it up just so that we can all be thinking it through. Okay, so this is what I'm looking at. If I'm going to draw one piece of cosine, except I don't have to write it every time, here's what I'm going to think through. Okay? Since I'm only doing 1 period, I know I'm going from 0 to 2 pi. All right? So I know that the cosine starts and ends at 1. Halfway, it's at -1. Halfway between each of those, it's at 0. So very quickly, I've drawn those 5 points, and then that quickly, I can draw the cosine. So that the whole thing probably took me 12 seconds, and that's because I was talking to you. Okay? So that's all we're looking for on that page. Just practice getting that picture burned in your brain using those 5 points.